Hello everyone, what do we have here? Have you ever thought of saving the world with nanocomposite technology? But wait, what in the world is that? Oh, it's just a nanomaterial that consists of multiple pieces. It is very small because it is a nanometer scale. In fact, it has been used extensively in many fields such as medicines, catalysts, oil and gas pipelines, and even in herbicides to be used in agriculture. But before we dive in, I'd like to present our team members. Hi, I'm Farah Liana. This is Ira Wahada. This is Nur Amira Aina, followed by Fadzil Idham, and the last one is Syahidatul Insyirah. Okay, let's move on. Herbicides, as we know, is a killing agent for weeds and has been used for so many years in agriculture. Weeds destroy your plants and decrease your crop's production. That's why weeds are bad and we must eliminate them. So our job is to produce these hybrid herbicides that can help contain these unwanted plants by experimenting zinc-layered hydroxide and the herbicide of our choice, which is the 2-methyl-4-chlorophenoxy acetate acid, or MCPA. Say yes to the hybrid herbicide, and it's environmentally friendly.
The usage of herbicides in plantation can lead to issues related to environmental pollution. As farmers use herbicides to control the growth of weeds, various pollution issues arises. For example, excessive usage of herbicides can lead to soil contamination. Not only that, the remaining herbicides that was not absorbed by plants will run off to water reservoir when raining occurred. Other than that, the herbicide too can vaporize up to the atmosphere that could lead to acid rain. In order to solve these issues related to environmental pollution, zinc layer hydroxide or ZLH are used as a host for herbicide. The ZLH is a class of inorganic compound which consists of the cationic brucite-like layers, or also known as hosts. The cationic layers or the positively charged layers are formed usually by metal ions and the hydroxide ions. This combination of cation and hydroxide will create a layer from the combination of a sheet of unit cell crystal. All the cells will rearrange itself to form the layer or the lamella. This layer then will stack together to form many layers. The hydroxide then will enclose the cation in the edges of unit cell, in which the cations will settle at the center of the octahedra and form the individual cell. In this study, we focuses on the usage of 4-chloro-2-methylphenoxyacetic acid or MCPA as the herbicide that will be intercalated with the ZLH host. This is the chemical structure of MCPA. MCPA are usually used to control the growth of broadleaf weeds such as thistle and dock. They are often used to protect and sustain the growth of corn in agriculture.
For a significant study, provides the efficient and safe delivery for the herbicides that control the weed crop, and to construct herbicides transportation which can minimize the release rate of herbicides while sustain the environmental system. For the first one, shows intense peak at 2 theta between 30 degree to 60 degree, which indicate high crystallinity of zinc oxide. At 0.1 molar MCPA, which is low concentration, shows the presence of pure zinc oxide peak due to appearance of zinc oxide in the composites. At 0.5 molar MCPA, which is high concentration, it shows intense peaks at 2 theta below than 10 degree. The peak indicates pure phase material where zinc oxide perfectly converted to zinc-layered double hydroxide. So, from these patterns, there's no impurities of MCPA detected, which indicate zinc MCPA is well ordered and has very good crystallinity. It only has 4 harmonic peaks that indicate successful intercalation of MCPA with zinc-layered hydroxide. The most important peak is number 1 and peak number 3.
Hi everyone, I'm Fazil and I will talk about spatial orientation. Spatial orientation is the theoretical arrangement for the gas anions inside the interlayer domain of the host molecule. In this project, the MCPA in its acetate form will realign itself at about 45 degrees to bond with the surface of the ZLH host. From the XRD pattern, the peak value 24.6 Armstrong denotes the basal spacing of the nanohybrid as shown here. By subtracting the crystal thickness of both the tetrahedron coordinated zinc atom and the octahedral coordinated zinc atom from the total basal spacing, we obtain the value of 14.6 Armstrong, which is the space left in the anion gallery for the MCPA to occupy. And here is the proposed molecular configuration of the MCPA. This animation pretty much sums up the MCPA intercalation.
Ladies and gentlemen, let's move to the FTIR spectroscopy. It is an analytical technique used to determine the functional group of the materials. As you can observe from this FTIR spectrum, there are 4 different spectra which indicate 4 different concentrations. As you can observe, for the highest concentration, which is 0.5 molar MCPA, there are presence of OH stretch for water, and there are very intense band for C-double-bond-C aromatic, COO stretch, COC stretch, and CCl. These are due to the compound that contain in the ZMCPA itself. The successful intercalation undergo control release by UVB spectrometry. Control release used to measure the percentage amount of MCPA that able to release in aqueous media, which are sodium chloride, sodium carbonate, and sodium phosphate. From the release profile, the highest percentage recorded at sodium phosphate due to phosphate have high anion value and high affinity to undergo ion exchange with MCPA. Therefore, sodium phosphate is the best media for MCPA to release by 85% compared with sodium carbonate and sodium chloride. As for the conclusion, the synthesis between ZLH and 0.5 molar MCPA was successfully intercalated to form ZMCPA by ion exchange reaction with hydrothermal treatment. Next, we can conclude that the release study of MCPA showed the slower release in sodium chloride and faster release in sodium phosphate for 360 minutes for each media solution. That's all from us. Thank you.